All right, I think I'm going to get started, and I'm sure we're going to probably get a few folks appearing a little later. Just want to make sure that you can hear me. So if you could go to the bottom of your screen where it says reaction and just hit the thumbs up so I can tell that you actually can hear me. With the zooming, we can never be certain if we're being heard. So just hit a thumbs up in the reaction, and I can then I'll know you can hear me speak. I'm assuming that I'm being heard. Sarah, you can hear me, can you?
Yes.
Good. Maybe unmute one person and see if they can hear me.
I've seen thumbs up. People are thumbs up. Yeah.
Okay, great. So we're off and running then. Super.
There was a comment about the humming in the background, but I said I think it's your computer, correct?
Yeah,
just a slight humming. Yeah.
Yeah, it might be the computer. I know I don't have any humming here.
I'm pretty sure it's your computer because it was from yesterday. So anyway.
Oh, was it?
It's all good.
Okay. All right. All right. Well, let's move forward. I think we've got at least half of the crew here now. And first off, I want to say thank you to all of you that have signed up today. Appreciate that many of you are interested in what we're going to discuss. I noticed there's a range of careers, and also there's a very good contingent of women who've signed up. I think that's wonderful. It's very promising for our industry, both in project management and engineering. We have a relatively large group, so interacting with one another may be a bit of a challenge. So likely what will happen is I'm going to pretty much go through the presentation and try and get everything in the short time that we have. We only have an hour, and thankfully with Zoom we can get together from far and wide, from different parts of the country, even the world, to discuss the topic at hand. And hopefully I can help those of you that are seeking more knowledge and information in terms of project management and engineering. I can hear you. Great. Super. Maybe you don't want to hear me. No, I'm just kidding. No. In any case, today I am not going to teach you to be project managers. What I will do is help you be aware of what project managers are tasked to do and how engineering fits with project management. You may be a very good engineer, but you may need some skill sets to make you a project manager. And again, we'll go through some of the things that a project manager needs to know, which hopefully will prompt you and motivate you to go and seek out more information to help you attain those skills and talents. And like any skill and talent, it takes time and it takes experience. So we'll do that. At the end of the presentation, I'm going to leave my contact information in the event that there's something else you might want to talk about, or you might have a question on. The other thing too is I also do coaching, and if your company's willing, I provide coaching support to individuals who may not have those kinds of abilities within their organization. So again, if your company is looking for coaching or mentoring in terms of project management, I would be available, and I can be reached in my contact. A little bit about myself, because you're probably wondering, who is this person and what the heck does he know? My early days, I wanted to be an architect, and that didn't pan out so well because I didn't have the talent. I went to several universities and showed my portfolio, and unfortunately my portfolio paled in comparison to some of the other talent that I saw at the interviews. So I ended up doing the next best thing. I attended Ryerson, and I got a 4-year Bachelor of Technology degree, and I majored in project management. So that was my career choice. If I couldn't design buildings, at least I could put them up. My career started in planning and scheduling. I worked with planning major projects. And when I started planning and scheduling, there were no computer software programs at the time. The early stages of planning and scheduling in a computer was was punch cards that you pushed into a computer and it spit out information in large sheets of paper. My career developed from there. I went from planning and scheduling. I learned about cost control, and then I got into other things such as coordination, and then ultimately ended up being a project manager looking after major projects. So over my 30 years of work, I was primarily focused on heavy industrial projects such as car plants, power plants, mining, steel making, paper making. I worked in all of those industries. We built large processing plants, and then finally into pipelines. My work took me from Canada across the country. I did projects in the US, and I spent a couple of years in the UAE and Dubai and Abu Dhabi building pipelines and gas distribution systems there. So that's a little bit about me, and so that'll give you some idea of my background, so that you recognize that I was someone who actually did do the things that I'm about to follow through with you. All right, well, let's move on now. I wish I could have a conversation with each and every one of you and learn more about yourselves, but obviously we don't have time for that. But perhaps if you want to contact later, I can get some more information. Some of you have already told me what your functions and responsibilities are, which is great, and I can see there's definitely potentials there. So, how engineering contributes to lean project management. And we're gonna follow on and discover how engineering contributes. So what is lean project management, and how does engineering contribute to it? First, lean project management requires improvement in productivity. Lean, as you know, as the word says, typically means you're trying to do it at the most efficient possible. It's reducing waste. It's reducing the amount of time required. It's reducing material and effort so that we don't waste. We want to make sure that everything we do is efficient and productive. It's an improvement in quality. Obviously, that requires that when we create a product, that it lasts and it doesn't have to be repaired or replaced, and has a longevity. There's less firefighting and more look-ahead planning and execution. So rather than sort of bumping into the wall and running into problems as we see, we've planned for them. We've looked at the risks, and we've made sure that we followed that plan. We execute it, and certainly a plan changes as we go, so we adjust and make changes. It also improves the workflow so that the operations we do are made once, and then the next operation occurs and it's done once. We're not doing things over and over again. And then we're controlling our operating costs. We want to make sure that we keep the cost of operating as low as possible so that we're not wasting energy, electricity, utilities, whatever the case may be. So that basically describes what lean project management does. And we can see how engineering contributes to that, because engineering contributes to just about every one of these functions. So what's our objective today? Today we want to assess the 6 main features of project management and how they apply to and are affected by engineering in the course of a construction project. Now, I worked in construction, but project management can be used in just about any industry, and it is. In chemical, it's in software, medical. So the principles of project management apply to many different aspects of our world. We want to increase our awareness. I want you to be aware of the need that is required to be a good project manager. Develop your understanding and how project management fits into the big picture. Then we'll have some examples. I'll go through some examples with you so you can see some of the documents that are used in project management. And hopefully what you'll get is some lessons today that you can take home and to work. To help organize not only your work, but maybe your home life. Maybe you're building a deck, maybe you're adding to your home, whatever the case may be. Some of these principles can be used to keep your costs down and your schedules on time. So at this point, I'd like to know a little bit more about you. Sarah's going to put up a poll, and all you have to do is click on the one that fits into your category, and I'll get an idea of where your talents lie, and where your skills are, and where your careers are taking you. All right, that's great. We have a large contingent of engineering, and that's expected, which is really good. And we have some project coordinators and project managers, so very good. Excellent. All right, we can call quits on that. Now that I've got an idea, and we'll proceed with that knowledge. All right. So, project management. That word is bandied around quite a bit. We hear it in a lot of industries, and it's not a sort of professional certification like, say, an engineer is, or a doctor or a lawyer, but it is a specific set of talents and skills that, although they're not sanctioned by any government certification board, they are an important feature in determining how things get built and done. What is project management? So the definition of project management: it's the process whereby you are called upon at the inception of a project to plan, coordinate, and control all the resources required to complete the project through to operation within an allotted time, an agreed budget, and a specific level of quality and safety. Project management means you take responsibility. You may not have authority in every case, but you take responsibility for ensuring that each one of those items is somehow monitored, managed, controlled, reported, whatever the case may be. And if there's deviation, you want to do something about it. You want to correct the situation. So we take responsibility. Being a project manager is a very responsible position, and the best thing you can do to gain credibility and respect is to be responsible. And even when the times are tough, you take it on the chin sometimes, but it actually builds your character and your career. So there's three types of project management. There's lean, agile, and waterfall. Lean, I think we talked about. It's basically driving waste out of the system. Agile is one that's used primarily in the software business, in the IT business. Agile basically is you take one step forward, you look around, see which direction to go next, and then you take another step in the direction you see as being the most profitable or the most successful. And you keep moving forward, not knowing what the end looks like. And then waterfall is the typical project management system that basically is like a chart where it goes down like a waterfall. You activity 1, activity 2, but what you do is you plan it right to the end so that you have a complete picture of what you're looking to do. 70% of project managers' time is spent fighting fires, which takes the PM away from managing a successful project outcome. This is one of the dreads of project management, is that we spend a lot of time fighting fires instead of planning for the future. Now, firefighters only spend 10 to 15% of their time actually fighting fires. So we need to learn from the firefighters. Let me go back to that. We need to learn from the firefighters, because through the years they've created regulations, rules, and that has reduced the need to fight fires. And we as project managers need to do the same. We need to follow the rules, follow procedures so that we don't fight fires. We plan ahead, do a lot more visual analysis of where we think we're going to prevent all those firefights that we have. Now, that doesn't mean that those fires aren't created by people around us, but we learn We learn by procedure and policy how to change that. A majority of our projects end in failure. In other words, we overshoot the original plan by over 5%. And I pick 5% because that's a good number. We know that no project typically comes in on budget, but if we are only at a 5% over, that's actually a pretty successful project. Now, if you can get under budget, that's phenomenal. But if you can hit the budget or be just a little bit over, then I think you're being successful. Bad projects probably run 10 and higher percent over budget. So, and there's reasons why that happened. So what is causing these failures? Well, number one is poor communication with stakeholders. And how does that happen? It happens because we have interpretation issues. Sometimes words in one person's mind mean something in another person's mind. So we have to ensure that interpretation is clear in everybody's minds in terms of what it is talking about. There's language barriers. If you're working in an environment where there's different languages being spoken, again, words being different things, and perhaps explanations aren't as clear in one language as they are in another. So it may require patience. Meetings is a forum for exchanging ideas and exchanging information. And if meetings aren't conducted properly, then we're not communicating very well, because it's one of the forums where we get the whole team together and we talk about the project and what needs to be corrected. Empathy is another communication skill, and that is to understand the other person's positions, trying to read the other person's difficulties or agendas, and understanding who they are and how you fit into the picture. So empathy is just basically understanding the people around you, their positions and their thoughts and theories, and giving them the opportunity to express them, and allow yourself to not be threatened by other people's thoughts and beliefs, only to be someone that hears and understands, but not necessarily has to be affected by what's being said. Poor relationship between stakeholders. Things can get personal sometimes. We want to avoid that. Information and data problems, incomplete, inaccurate, unclear. And that can create failures. Inaccurate estimates. Quite often estimates are not complete, or they come short of the number. And so therefore, we go forward thinking things are going to cost a certain amount and it takes longer or it costs more. Conflicts unresolved. We have a bit of a conflict with a stakeholder, and rather than deal with it, we let it fester and it becomes a bigger problem as time goes by instead of dealing with it at that moment. Mistakes and errors in engineering and construction. We all understand that errors are made. What we want to do is minimize them and keep them to a level where they can be corrected fairly rapidly. And we also want to keep it down, keep the numbers very low. Lack of effective project management skills, as I mentioned earlier. Skills are something that you can learn over time. Things that you can be taught, things that you can watch other people do who are good at what they do. Lack of experience and proper training. This is talking between an amateur and a professional. What's the difference? A professional spends more time in the detail. An amateur tends to be more general. So to become a better project manager, you have to spend more time in the detail. Get right down to the detail, and that makes you a professional. The disappearance of mentorship. This is something that used to happen in the past. Is basically as a junior, you would follow a senior around and kind of learn from them. That doesn't happen anymore. Companies can't afford that sort of overhead. So basically you're getting bits and pieces of information from different people in the organization, and you're trying to thread it all together to become a project manager. That can work. It takes a long time, and sometimes it can work against you because you're getting bad training. Lack of competent oversight. We go to school, we have teachers who look over our shoulders to make sure that we're doing our homework properly or we're doing our assignment correctly. We would have some sort of advantage if we had that sort of opportunity at our work. If somebody looked over our shoulder every once in a while, then just to make sure that things were going according to plan. And the lack of complete documentation. How many of us have had to suffer through information that's lacking? We don't have everything we need to know, and we have to dig deeper, or we have to ask more questions. Requests for information are issued because there's a lack of documentation. We don't have a complete manual or whatever the case may be. So why use project management methods? It helps focus on our objectives. We have an objective, we want to focus on it, and project management methods will help us get there. It increases your level of confidence. To be a good project manager, you have to have a good level of confidence. You have to recognize things in advance. You have to be prepared for things that may or may not work out for you, but you want to have that confidence in knowing what the proper route is to finding success in your career or your project. Project management helps you plan your resources productively. You're not just haphazardly bringing resources to the plan and not knowing how they're going to affect your outcome. By planning your resources, it means you want things to appear when they're needed and to disappear when they're no longer needed. And that is good planning. It provides a game plan to reduce failure, and that ultimately what we want to do is we want to reduce failure. We want successes throughout our project. It builds your project on paper or in software, because that is the cheapest way to build. Because if the information is not done and the planning is not completed, then what happens is you're starting to build it at full scale. And at full scale, things cost more to correct as opposed to doing it on paper. It helps reduce conflict through good communication and documentation. We want to reduce conflict. We want to ensure that documentation is clear and concise. We want to make sure our communication is well understood by all the team members. So engineering. What is engineering? Engineering is the initial stage of project management. It's a crucial stage because it basically sets everything in motion. What do the engineers do? They sit down, they do studies, they check capital costs, they review expenses, they look at the process, and they help the owner decide, do I want to move forward with this project, or do I shelve it? Do we redesign it? What's our capacity? What's the output? How much can I make from it? How much is going to cost? From there, we issue drawings. We might have some preliminary drawings, but in them we have a certain level of accuracy in them so that decisions can be made. And then if the decision is made to move forward, then engineering moves on to specifications for materials and equipment. This is sort of the quality aspect of engineering. And then we go to the bid drawings. Now we're going to put these drawings out for bid. And what I like to do prior to bid drawings is have those drawings reviewed by disciplines. I might hire a mechanical journeyman, a senior mechanical journeyman, a senior electrical journeyman. I want them to look at the drawings like they're the contractor. And I want them to redline them and highlight them and send them back to me so that I can say, okay, let's review this and see if we can make these adjustments, because we want to reduce the amount of changes that happen in the field, and we want to reduce the cost of installation. So once that process is complete, the pricing is in, we've picked our contractor. Now we go and we issue those drawings for construction. And at this point, those drawings should be 80 to 90% complete. Should be few errors in them. In the real world, that may not happen, but that is what we want to achieve. Because if the drawings are complete and there's very little interpretation in it, then that reduces the number of changes and notices that have to be issued during the project, which helps to reduce failure. And also the constructability. When those drawings are issued, we want to ensure that they are constructible, that we're not going to be spending a lot of time and effort trying to complete the install through the documents we've received. So as I mentioned, engineering is for the first step of project management. At the start of this process, there should be a project manager who's reviewing all of this and overseeing it all as well, because now the next step is to execute those documents and turn them into a physical structure. So here's the 6 main controls and deliverables. We have scope, we have time, cost, quality, resources, and safety. And these 6 aspects play a major role in the success of a project. If any one of them becomes a problem, it can affect the others. If you have an issue with scope, then if we have an issue with scope, then it can affect the quality and the resources. If we have an issue with quality, that can affect time and cost. If resources are a problem, that too can affect time and cost. So you've got to recognize that one of these things could create a domino effect and affect your project in total. So what's the scope? Scope, define what it is required in detail, words and drawings. And that's all the scope is. It's basically, here's what we're planning to do. It's a set of drawings coupled with words to define the project. We want to avoid interpretations. We want to clarity in defining the requirements so we know exactly what it is we're trying to achieve. We want to be able to take that document and hand it to someone, and they should have no problem in understanding what it is we're trying to find, or we're trying to create here. The product scope is what? What is it that we're trying to achieve? And the project scope is the how. How do we get there? How do we make this happen? We create a work breakdown. It's a work breakdown structure. Basically, we break down the scope into little bits that are easy to manage, something that's quantitative. We can quantify it. We can assign a cost to it. We can also assign a schedule or a time to it. It's specific, it's measurable, it's attainable, and it's realistic. We don't want to create a scope that's impossible to create. Then it's beyond the realms of the scope. It's more of a fantasy. But what we want is we want to have something that we can look at and we can visualize, or we can draw it on paper and recognize it as something that can be done and built. Scope is well defined. Scope, it reduces effects of change order, so that if your scope is clear and concise, your change order quantities, numbers will also reduce. You won't have as many changes on the job. You will run into fewer conflicts in terms of the install. So here's a little bit of an animation of how scope can affect a project. And you can see there's a scope that was required by the user, and you can see what happens when interpretations don't always follow the initial scope. Now, it's likely the scope wasn't written very well, and so everyone interpreted the scope in their own fashion. Next is time control. In time control, there's several methods. There's seat of the pants, and you use your memory, you rely on it. You have a mobile phone, has a calendar in there, you control your time that. You can write lists and put times next to them. If you have a day timer or a journal, you can use that as a time control. And then there's time scale charts, Gantt charts. Those are ones we typically see. We see these bars and we see, well, here's a bar there, there's another bar there. And we can't really visualize the work as well on Gantt charts, but we can at least see the timing. And then there's computer applications like Microsoft and P6. Some of you may have used some of these software programs. They're very helpful. It's good to understand how they work, how they're set up, the calculations that occur in them, particularly if you're having a critical path, that you're trying to define a critical path. So again, it's good to know these forms of time control, because the more sophisticated the time control, the more success you will in achieving your schedule, and the better defined the schedule is. So time control, it's basically taking that work breakdown structure that we talked about earlier and setting it to time. We've broken the work down into bits and pieces, and now we've set a time frame to each one of them, and then we define the relationship between each one of those activities. The work breakdown structure is the key initial activity. It sets the project in motion. It has to be measurable. I like to keep it approximately 200 hours of effort per activity on the work breakdown structure. We estimate the duration. 200 hours can happen in a week. It can happen in 6 weeks, depending on how many resources we apply to that activity. When we sequence those activities, we say that A B cannot happen until A is complete, or B cannot finish before A is complete, or A and B have to finish at the same time. So that's sequencing the activities, and we use that logic based on our experience in terms of building. From all that, we determine a critical path. We determine a critical path, which tells us the critical path is the longest path through the schedule. That defines how long the project will take, because those activities are basically the longest activities that connect to one another, that leads to the end date. Every other activity outside of the critical path has a bit of float, which means that you might have a day, a week, or a month of time before the activity has to be completed. The activities on the critical path must meet the time frames, because if you miss by a day, you lose a day at the very end of the job. And again, software helps to determine the critical path. You want to monitor your progress and project the future. That's the other part of time control. It's not only monitoring and knowing where you actually stand, but where are we going? Are we going to meet our obligations? Are we going to meet our deadlines? And then you want to ensure validity and accuracy of inputs. So having time control is nice, but make sure that what you're inputting in is correct and that the durations are right, the resources are correct. Because again, whatever you input, if you input garbage, you're going to get out garbage. So important to make sure that your time controls are robust, accurate, and you've vetted them to the point where you're pretty sure that all the information in there is as accurate as you can get it. And that might mean you go back to the original estimate and utilize the estimate to create your schedules. So another aspect of scheduling, it's nice if you know how to use these software packages, but if you don't understand what it is you're scheduling, it can create some problems. So ensure that if you're going to do any scheduling of a project, understand the project so that you know how it works and how things fit together, so that you don't go blindly forward thinking that everything's going great when in fact things aren't going as well as you'd like. Next is cost control. This is where we take that work breakdown and we labor it and price it. And that means we assign resources and the cost of those resources. So we use estimated costs. Sometimes the project manager gets involved in those estimated costs because he's responsible and he wants to ensure that he feels comfortable that we're assigning the right values to these activities. How do we get those costs? We research them. We might look at previous projects. We might look at current ones that are out there. We might just use the estimator's estimate because theoretically he should know. We might look at history. And what we do is we want to determine what the cost of material and the cost of labor is going to be. And we use those to define the project cost. And then we add some contingencies for the unknowns. Now, we can either add the contingency at the very end of the estimate, or let me just get back here. Oops. Sorry about that, folks. Get back to where I was. Contingencies, monitoring software. So the software also wants to monitor our costs. So we have a forecast to complete, we have actual cost, and then we have forecast to complete based on the productivity that we're experiencing on our project. And our software packages will help us determine those things. Next is quality, and that's defined by engineering. It's the ability of features and characteristics of a product or service to satisfy stated and implied needs. So again, if the documentation defines clearly what the requirements are of the project, then you've basically defined the quality. And that usually follows codes and regulations. It also provides levels of expectations. Certain industries require certain levels of expectations that maybe go beyond codes and regulations. They also have to be recognized and uniform. And some of the recognized and uniform methods may involve maybe pressure piping, maybe materials testing, whatever the case may be. And then the other aspect of quality is to monitor and verify. It's not good enough to just hand out a set of specs and say, here, build this. Now you want to make sure it does get built. And that means checking and verifying. So it might require creating test reports, inspection and test programs, verifying that things have been built according to the drawings, getting people to sign those test reports, maybe having inspectors, whatever the case may be, to verify that the quality has been built into the project. So as I said, quality requires checking, and checklists are always useful in a quality test, and also provides historical documentation in the event that something should occur in the future. You can always go back to your documentation and verify that yes, it was built in accordance with the drawings and specifications. Resources, the next aspect. This is all the elements required to complete the project. That involves things like the labor, the money, the equipment, the tools, and the time, all of the aspects required to build the project. It involves procurement, which means purchasing. You're purchasing products, you're purchasing materials. It also involves contracting. You're going to contract out work to actually do the physical install. In determining resources, you have to decide on what quantities of resources you need. How many people are needed to build the project? How many pieces of equipment? What size of equipment do you need? Do you need cranes? Do you need forklifts? Do you need pickups? What do you need? People, your staff. How many people do you need on your staff in order to perform the project? That's another resource, and it's another resource that you want to have competent people on your staff. As a project manager, you want people on your staff who are very competent in what they do. It makes your job that much easier. If you have the ability to hire your own people, you want to interview them. And if you've had the opportunity to try most of the jobs like document control or quality control or safety, whatever the case may be, if you've had an opportunity to go through all those functions in your life and in your career, when you achieve project management status, you'll understand each one of those types of positions in your organization, and you will be better prepared to hire competent staff. Also, you want to plan down to the team doing the work. When you do the planning, you want to recognize that it takes 2 or 3 individuals to build a particular part of that project. We don't want to just look in general to the whole project in one big picture. We want to look down to the actual team of people that are doing the work. And other part of resources is our software programs. We need software programs to manage our data, our documents, our money, our time, and resources. These are aids to project management that avoids the manual task of doing all of these things. Now, years ago, it was all done manually with Excel and spreadsheets and so on. But now we have the benefit of software programs that can handle a massive amount of data, especially as our projects become more complicated and immense. So here's a typical organization chart. You have the owner at the top, and you have procurement. You see project manager basically looks over the entire operation. You can see construction, engineering, and vendors in there. This is just a generalized organization chart. They can take different forms, but this is kind of a look as to how engineering, project management, construction all fit together. Safety. Safety is development of safety policies, creating safe procedures and metrics. It's following the law and regulation. It's creating, it's instructing and monitoring compliance to ensure people are working in a safe manner. It involves continuous improvements. If we see in situations that look unsafe, we want to find ways to improve and reduce the amount of harm that can be occurred. Engineering design for safe construction. So when engineers design a project, they look at it in terms of, can this be safely constructed? And they look at the different options and ways of putting a building together so that it avoids harm. Everyone goes home unharmed. This is a very important aspect in project management, and project managers have to recognize that safety plays probably one of the key aspects, because we don't want anybody to get hurt. And also, it's also can create some very crucial issues when it comes to neglect, because those can be criminal offenses. Police come to a job site when there's a serious incident. So you want to avoid that, because it can cause a real problem in your project. It can stop your project and until an investigation is completed. So you always want to ensure that safety is foremost in your mind when it comes to project work. So let's look at some examples. So here's scope. There on the left you have a scope document, and on the right you have a quality document. And you can see in the scope, basically it's just a description of what needs to be done, how it needs to be done. And on the right you see a quality scope, which basically defines the different regulations and permitting and codes that have to be followed. And that explains scope and quality. Next, we have time, cost, and resources. And you can see here on the left side, we see the work breakdown. The work's been broken down between concept, procurement, construction, and closeout. And then we list all the activities under each one of those major headings. We also have a column that says float. How much time do we have for that activity to slide? If it has a 11 days float, it means that if that activity is delayed by 11 days, it's not going to create a delay in the entire project. The things that have zero float are critical. Those activities have to happen. The next, we have the resources. We've listed the different resources. We have laborers, carpenters, electricians. And then we've also estimated the cost for each one of those activities. And next to that, we can have actual cost. Now, on a small project, you can do this sort of thing. On a major project, it's a little more challenging to put a cost against activities. You may run a cost system separately, but also using schedule to sort of help you determine the cash flow of money and so forth. And then we have the durations, and that tells you how long the activity is going to take. And you can see over to the right the waterfall effect, and this is why it's called waterfall. You can see the waterfall effect of how each activity relates to the next. And then at the very bottom, you can see the different resources and the number of hours that they're going to take to do those functions. And then from that, we create an S-curve, which tells us this is the progress that we intend to make in order to complete on time. And as we go along, we can put in the actual hours spent, and then that helps us determine the actual progress. And then there'll be another line that follows either on that curve, below it, or above it. If the actual curve is below it, then you're falling behind schedule. If it's above, you're ahead of schedule, and it can tell you the trend. I like using the S-curve because it gives me a trend analysis and lets me know whether we're moving in the right direction or not. Usually you have to wait till you're about 20% complete before that trend actually starts to make sense to you as to whether or not you really are trending in the right direction. But again, this is all data. Safety, this is just an example of a safety orientation. When a new employee comes on site, you go through all of these activities to make sure, all of these items to make sure that they're aware of how to conduct themselves in a safe manner. And then here is a pre-task plan, which everyone on construction has to take part in. Prior to any activity, we have to list what it is we're going to do, what the hazards are, how do we control those hazards, and what are the contingency plans. So again, it's just another aspect of safety. And gives everybody sort of a heads up of what we're going to do, how we're going to do it, and what are the hazards. So another thing about projects is risk. And how do we avoid risk? Well, risk is one of those things that you're really not aware of until you're almost on top of it, but you can plan for it. So we have the degrees of risk. We have a very severe risk. We have a frequency. We determine whether it's manageable and visibility of the consequences. And what are the sources of risk? There's technical and specifications, as we said in the drawings. Contractual, maybe we signed a bad contract. And then there's financial risk. And you can see on the chart, at the initial stages, we have a lot of uncertainty when it comes to risk. We're really not sure. But as we progress through the project, we come to certainty. We determine that we are certain about the risks. So we try and develop a plan where we can try and turn that uncertainty into certainty at these earliest of stages. On the right-hand side, you see the progress through the project life. And you can see that at the very initial stages of a project, that the opportunity to reduce risk is at its highest, or because the amount at stake is at the lowest. And that's why I say it's easier to correct paperwork than it is to correct in the field. As time progresses and we get into construction, the risks get higher, the stakes are higher, the opportunity to reduce the risks are lower. So it's extremely important to plan your project up front, get the paperwork in order, make sure the documentation is correct, it's clear, it's concise, so that we can reduce the risk. We ensure that our planning takes into account the potential risk. So here's just a bit of an explanation of the different types of risk. We have the high probability and low impact risk. We have low probability and low impact risk. We have low probability, high impact risk, and then we have high probability and high impact risk. So if trying to determine the category of risk that you're dealing with, you want to emphasize, or at least you want to focus on the things that are going to cause you a high impact. The low risk, sometimes you may just say, okay, well, we'll cross that bridge when we get there. But if we know we have a high impact and a high risk, we want to address that early so that we're prepared should it occur. Work breakdown structure. Here's an example of a work breakdown structure. We're going to build a bicycle. Well, what do we need? Okay, well, level 2. We know we need a frame, a crankset, we need wheels, braking system. And then we go to level 3, which breaks that down even further. And level 3 typically is where we start to do our planning functions, and we start to assign resources and quantities to achieve our completions. Again, a rule of thumb is I like to go 200 hours for each activity. When you go out for bid, I also like to use my work breakdown structure level 2 or 3 as my bid breakdown. I want contractors to price each one of these activities. So when we get into the construction, I can actually turn that into an invoice and also monitor the progress of their work. All right, here's an engineering work plan. And we say, well, how can we plan engineering? Well, it's like planning construction. Basically, we break down the number of drawings, number of hours it's going to take, and we may not know how many drawings it's going to take, but we take our best guess. We take those drawings, we list them, we hour them, and then we spread them across time. And as we progress, we determine at what level a particular drawing is at. So you might say, well, a drawing, as soon as you put a title block on it, it's worth 5%. If you've done enough sort of general drawing, you might give it 10%. If it gets to a certain point, say it's a review, that might be 60%. So you use that sort of guide to determine where your drawing is. And if the drawing count changes, you can change the chart. And what it does is it just reassesses your percentage and where you are in progress. But engineering can be planned. As a project manager, it's always good to get a handle on engineering because engineering affects construction. And here's a construction schedule, very same sort of thing. We spread the different aspects over the life of the project, and we monitor as we go along, and we determine whether we're on schedule or not. And here's how we see engineering and construction work hand in hand. As you can see, it's two progress curves, engineering and construction. If engineering is delayed, then lo and behold, construction is going to be delayed. So that's why we want to ensure that we follow the engineering trend curve. Because if there's any blip in the engineering, it's likely going to manifest itself in the construction build as well. So accurate engineering and on-time engineering will give us a good construction build schedule as well. So here's resources. So that chart we saw with the engineering schedule on it, we resourced it. Now we have a chart that says here's how many engineering types we need in order to accomplish the engineering schedule, and we can monitor this and keep track of it. Schedule, CPM schedules. How many of you have seen CPM schedules? They're just a network spaghetti diagram, and we want to ensure that those networks are robust and complete. We want to make sure that we're not, using fantasy like in this particular one. Then a miracle occurs here. That can't happen on a real project. We have to have it well defined and planned out so that we know what's going to happen. And schedules can be adjusted. So how do we trend? How do we keep track of engineering? Well, there's key performance indicators. If you're going to create some sort of a summary of how well engineering is doing, these are some of the key performance indicators. We want to know the number of documents that there are and how many are completed over time. We want to know how many have started, how many have been reviewed, how many have been issued for bid, how many are issued for construction. This helps to define percent complete versus a plan versus earned. And also helps us determine resources that are planned and actual. Quality KPI. What are the things we want to know in quality? We want to know the number of non-conformances. If something does not conform to the quality requirements, then we issue a non-conformance. A project that has a high number of non-conformances is probably a project that's in trouble because something's not right. Either the engineering is not right or the execution is not right. We want to understand the number of rework requests, number of drawing revisions as a percent of the original drawings. If there's a lot of revisions going on, then the quality of the engineering probably isn't up to standard. And we want to recognize that and maybe get it taken care of as soon as possible. What are construction KPIs? In there, we want percent complete planned versus actual versus earned. So if you are planned to be 50% complete and you're actually 40%, but you've only earned 30%. And again, that's a function of productivity. We want to know what our planned resources are versus our actual. We want to know what the critical activities are, because as a project manager, we want to key in on those activities. Those are the activities that are going to get us to the finish line on time. We want to know what our productivity by trade or commodity. How many hours per foot of pipe are we installing? What rate are we planned and what rate are we actual? How many feet of cable are we installing per hour? How many terminations are we doing per hour? Things of that nature. In number of RFIs and average response time. If you're having a lot of RFIs, requests for informations on a project, and it's taking 2 weeks to respond to those, that's going to affect your construction bill. So you want to make sure the turnover is quick. All right. This is project manager. As you can see, there's different people see project managers in different ways. What my friends think I do, what my mom thinks I do, what my boss thinks I do, what society thinks I do, what I think I do, but look at what we really do. And this is where I say we try and avoid and we try and stop fighting fires. And Sarah, I think this is where you wanted to post something. There you go. All right. So now that I've completed it to this point, we want to thank our partners. These are the organizations that helped make this happen. Certainly your patronage is valued by each one of these organizations, and even if you send them a thank you note as well for sponsoring this event. We've enjoyed very much being part of it and helping all of you to understand a little better some of the things that engineering and project management have to offer. So thank you very much. I enjoyed this time. I wish we had a little more time to talk about more things. If there's anything you want to know, by all means, there's my email address. And And I'm also available on LinkedIn if you want to connect. I want to bring to your attention, if you're on LinkedIn, there is one person on LinkedIn. Her name is Cherry Alex, PMP, PMI, SP. She's from ACOM. She posts a lot of great information when it comes to project management. It's all free. And I would highly suggest that if you're on LinkedIn, is follow Cherry Alex and go through all of the topics that she's posted over the past 6 months or so. She has identified just about everything I've talked about in here, and it gives you an opportunity to sort of learn at your own pace as opposed to a little bit rushed here. All right, that ends my presentation. I wish there was more time. I want to answer your questions. If you send me questions to my email, I will answer you. I won't answer you like in the next hour or so, but I will send you an answer. I'm sorry that there wasn't more time for us to discuss some of these issues, but I hope you've gained some knowledge and understanding. And hopefully those of you that are seeking to become project managers will dig deeper and find some successes. And those of you that are in engineering and aspiring to get into project management, you have a good basic start in understanding engineering and construction, and it's just a matter of picking up those skills and how to manage. So again, thank you very much. I appreciate all of you that have signed up, and I hope that we can help you in your future endeavors. All right, I'm done here, Sarah. I don't think I have enough time to answer anybody's questions right now, but I'll be happy to answer them by email.
Okay, perfect. I'll be sending you the 2 questions that came in directly to you, okay?
Great, thank you very much.
Okay.